Hello everyone, this is XM Physics. In this video, we are going to pin down the formula for the electric field strength of a point charge. So consider two charges here, big Q and small q, separated by a distance r. One view is that there's a kQq over r square electric force between them. This is Coulomb's law. The other view is that big Q is producing an electric field E around it, which results in the small q experiencing a F equals to QE force. So what should E be? Now see, the first view says that small q is experiencing a force of kQq over r square. The second view says that the small q is experiencing a force of QE. So just look, see, you will realize that E is kq over r square. That's right. The strength of the electric field produced by a point charge is given by the formula E is equals to kq over r square. So from the formula, you can see that the field is centered about the source charge and it acts radially outward. So a positive test charge will experience an outward force, and a negative test charge will experience an inward force. Magnitude-wise, the field obeys the inverse square law, so it weakens rapidly from the point charge. What about a negative source charge? Well, everything is the same, including the formula kq over r square. The only difference is that it's an inward field. So a positive test charge will experience an inward force, and a negative test charge will experience an outward force. So it's like a positive test charge produces a field that blows, whereas a negative source charge produces a field that sucks. But you know, everything is upside down and inside out for negative charges. So negative charges will be sucked into a blowing field and blown away by a sucking field. This is XM Physics. I try to make studying physics fun. If you enjoyed this video, please like, share and subscribe. Thank you. Ta-ta!